Hey guys, welcome back to this course on Smashtest. Now, in some of the previous lessons, we talked about how Smashtest comes with several built-in packages, one of which exposes steps for web UI testing, that is, automated testing in an actual browser using Selenium WebDriver. Today I'm going to go over how to build those web UI tests, namely a quick overview of some of the steps available to you. And then for the rest of the lesson, I'm going to cover ElementFinders, which are a unique way of locating elements on a page. Let's dive right in. So here are the steps for opening up a browser. Not surprisingly, they must come first in your test, as they expose all other browser-related steps and functionality. You can selectively run tests for one or more specific browsers by feeding in the groups flag at the command line, like so. Otherwise, they will all run. Somewhere under the Open Browser step, you can specify the viewport of your browser. These will set the dimensions of the browser window to a certain preset. The viewport will actually be set retroactively and take effect at the Open Browser step. If you omit a viewport, it'll be whatever the browser default is. And since you're probably running these on a desktop machine, it'll probably be something big and desktop-like, though not guaranteed. There are many more viewports and devices you can set, and they're all documented on smashtest.io. Now let's do a refresher on the onViewport pattern that we discussed in the previous lesson. When onDesktop is called, it will call desktop, which retroactively sets the size of the browser created in Open Chrome, and also exposes a login function. So when login is called, if we're on the desktop branch, the desktop version of login is called. The same principle applies to on mobile. You'll find yourself using this pattern quite a bit if you're testing responsive apps, or apps that have different flows depending on the viewport. The function navigate to my site is viewport agnostic. It's the same for desktop or mobile, so it's declared only once and on the global level, that is, at 0 indents. As time goes on, we may want to test in more browsers, so all we do is add them to this step block. Or we can put them in their own function, Open Browser, which is especially helpful if we have multiple tests in multiple files. Speaking of multiple files, if this file ends up getting too big, we can split it up like so. Let's do an overview of the most popular browser-related steps, starting with the navigation, since you'll be using these extensively. All of these steps are defined in the context of the Open Browser step, so they must come after that step. Navigate just sends the browser to the given absolute URL. It can also take a relative URL once you're already at a site. Another common pattern is to use a host variable substitution in a URL and set the variable outside the test, such as in the G command line flag. Nav is synonymous with navigate. And of course, you can go back and forward or do a refresh. Here are the interact category steps that deal with clicking, hovering, scrolling, and checking. ElementFinders are just strings, really awesome strings, that identify elements on the page, kind of like an advanced CSS selector. We'll talk about them in a bit. Another thing to note is that certain steps, particularly clicks, only search for the target element amongst elements that are clickable, and only if one isn't found do they search amongst all elements. This makes it easier to find what you meant to click in the first place. Here are some of the set steps for typing, clearing an element, setting an element's value, and selecting an element from a dropdown. These are mostly self-explanatory. The only thing I want to explicitly point out are the brackets inside some of the strings. Some keyboard keys can be surrounded in brackets and put into the string to be typed in. So for example, this means type in text, then hit the enter key. There's also a none in brackets, which is a bit special. This tells the step not to do anything at all. So why does this exist? Well, when you have multiple permutations, you may want to include an action as one of them, like so. Unlike the other permutations that choose a country name from the dropdown, this one will just leave the default dropdown value in place. It's much cleaner to list none as one of the permutations rather than coming up with a completely separate branch that omits the select step to begin with. There are many more steps available, from dealing with the browser window, to alerts, to cookies and storage, to logging, to various forms of mocking. The full list of steps are on, of all places, Smashtest.io, along with really helpful documentation. So check that out. Here are the verify steps for asserting that an element is visible or not visible. You can also use these steps to verify the state of an element on the page. So for example, instead of saying something like verify button is green, you'd say verify green button is visible. Not visible is the inverse. An element isn't visible if it's either in the DOM but not visible to the user, or non-existent at all. Smashtest makes no distinction between the two. And here are the various ways of asserting the current browser location, either with a string the page title ought to contain, a string the URL ought to contain, or with a regex that ought to match the page title or the URL. Verify steps wait for up to 2 seconds to become true, otherwise they will fail. To wait longer, use wait until instead of verify. Each verify step has an equivalent wait until step. Wait until will wait up to 15 seconds before failing. To wait even longer, or to wait for a specified amount of time, add up to n seconds to the end. You can also do verifications from a code block using the $sign function. We'll cover it in detail when we talk about ElementFinders. Actually, speaking of ElementFinders, ladies and gentlemen, presenting ElementFinders. Simply put, an element finder, or EF for short, is a string that matches elements on a page. But you already knew that. In these steps, the string passed into click is an element finder. Each line consists of a comma-separated list of smaller strings called props. A prop, short for property, describes an element or the state of an element. To match an element finder, an element must match all the props in the list. In the first example, the EF is login button, which is a list of one prop, login button. It will match elements which match the definition of a login button. The second example contains 3 props, button, enabled, and red. It will match elements which match the description of a button, something that's enabled, and something that's red. The third example contains 1 prop, submit, where the quotes are part of the prop. It will match elements which contain the text submit. And the fourth example contains 2 props, follow and next to Bob. It will take the elements that contain the text follow, then choose the one that's closest in the DOM to the text Bob, and match that one. Props are applied from left to right. You start with all elements in the DOM, and as each prop is applied, it chooses a subset of the remaining elements to go on to the next round. The elements that survive after all props are applied are the ones that match the EF. We'll discuss how to define props in a bit. So that's your standard run-of-the-mill comma-separated prop list. Another way of listing props is in a space-separated prop list, which are usually easier to read. For example, red button sounds so much better than button comma red. In the first example, Smashtest will check to see if red button is a defined prop. If not, it'll assume the space to be a separator and will apply the prop red followed by the prop button. In the second example, we again have 2 props. The text login, which matches elements that contain the text login, and the prop button. In the third example, we've added a prop to the front. Fourth is known as an ord or ordinal. Even though it's listed first, it'll be applied last. This is the only exception to the left to right rule and is done for readability's sake. So here we'll apply login, then apply a button, then choose the fourth element that's left, and that's what will be clicked. In this example, suppose a blue button and enabled are defined. Since blue button is defined, Smashtest will recognize this as a list of two props, enabled and blue button. Space-separated prop lists are very handy in that they sound very natural. I highly recommend that you use space-separated props inside of steps for this very reason. Your steps will be outputted to the report and console, where humans will have to read them. Even if you don't like humans, hey, they still have to read it. And you'll have to read your own report and code at some later time, right? So avoid comma use in steps, or use commas inside of code blocks, which we'll discuss soon. Of course, there are exceptions. Because spaces can be ambiguous, commas are sometimes necessary. In this example, is launch a piece of text that an element should contain, or is it the input for next to? For this reason, this kind of EF is not allowed. We have to put a comma before next to. Now it's obvious what the text does. It's what the button has to be next to. Notice how enabled red button is still a space-separated list. That's okay, you can totally mix and match. I don't mind you using a comma here since it reads very naturally. You're looking for an enabled red button, one that happens to be next to the word launch. Also, if you find that an EF is getting very long, I highly recommend you define it as a new prop and use that in your steps. Now let's go over the different types of props. We've already seen the first one. When the whole prop is just text and quotes, it means match all the elements that contain this text, either an inner text or value, placeholder, associated labels inner text, or the text of the currently selected option in a select. It's case insensitive, ignores leading and trailing white space in both the string and the DOM, and treats all other white space as a single space, both in the string and in the DOM. In other words, it's a loose match. By contains, I mean the text is a subset. There may be other text inside the matching element. Because of this, I want you to be on the lookout for multiple elements containing the same text. For example, if I'm looking for 9 in quotes, and there are two buttons, one with 99 and one with 9, and the 99 comes first in the DOM, the 99 will be the one that's matched first. In this case, you might want to look into the contains exact prop, which takes in as input the exact text you want inside the element in question. Next are the ords or ordinals. These take all the elements matched by props so far and choose the nth one. So after an ord is applied, only one element remains standing. This is why you usually list them last in a list of comma-separated props. In space-separated props, always list the ord first. It will still be applied last. Some props take in a string of input after their name. Examples of predefined props that take input include next to, xpath, contains, and style. These props must be separated from other props using commas. If a prop doesn't match any existing defined prop and is in an ord, it'll be assumed to be a CSS selector. Yes, a plain old CSS selector. Any CSS selector can be used, but be careful when using selectors containing commas or brackets, since these have special meaning in ElementFinders and may be misinterpreted. In such a case, use the selector prop and put your CSS selector inside the quotes. Since the CSS selector by itself is a valid prop, And since a prop by itself is a valid EF, a CSS selector by itself is a valid EF. However, please don't use a pure CSS selector inside the text of a step. Those should be human readable. Instead, define a prop and use that prop inside the step. Smashtest comes with a bunch of predefined props, mostly related to the state of an element, such as visibility, clickability, enabled, selected, focused, etc. Other props are related to the page title or URL, proximity of an element to a piece of text, style, position, and ways of matching elements with a specific locator, such as a CSS selector, XPath, or inner text. And the text box prop matches any kind of text box or text area. Aside from the props you use in your EFs, a few props are implicitly added under the hood. One of these is the visible property, which matches elements that are visible to the user. It determines this by looking at opacity, width, height, display style, and a bunch of other properties. By default, the visible property is appended to the front of any prop list. This makes sense. If the user can't see the element, it doesn't exist for him. To override this, include the any visibility prop anywhere in the list. Of course, this will match all elements regardless of visibility. Now, why would you ever want to do that? Well, in rare occasions, you may find the easiest way to implement something, or to get around a WebDriver limitation, is to click on something that's hidden from view. Or you may want to do something like verify the contents of a dropdown. The option elements inside of a select are by their very nature invisible, and thus require this override. Also, if you define a prop using any visibility, you must continue using any visibility when using that prop. In this example, a blue button is defined with a CSS selector and any visibility. Later, when that prop is used in a click step, we still use any visibility, since otherwise, visible will be implicitly added again. The other implicit prop is clickable. Some steps, like click, prefer to find elements that are clickable. To do this, they quietly tack on a clickable prop onto any EF you pass in. Without getting too deep into the details, an element is clickable if it's expected to handle a click event, such as a link, button, input, select, or element with a cursor style set to pointer. If no elements are found with clickable attached, the click step will retry the search, only without clickable. This handles scenarios where you want to click an unconventional element, like an image or a div. Implicit clickable is also why steps like this work. Although the word submit may appear in many places on the page, only the visible button containing submit is actually clicked. This will save you time in not having to find out what the submit button selector or other internals are. You just choose it by its text. So how can we define our own props? The best place to define them is in the onPage function that we discussed before. We call onPage when we've just arrived at that page and want to expose functions, do some verifications, and of course, set defined props particular to that page. You can just call the built-in props function from your code block. Props takes an object, where each key is the prop name and each value is a string, which is either an element finder or a function. To keep things simple, I'm only going to cover the element finder option for now. Once a prop is defined, it remains accessible throughout the rest of the branch until it's explicitly overridden. You might have noticed it's not human readable, but that's totally okay. The contents of code blocks are meant to be code. Unlike the text of a step, which is meant to be human readable, a code block isn't rendered into the report. It's just executed behind the scenes. Since complex EFs and CSS selectors are code themselves, they are more than welcome inside the guts of a code block. To get hold of an element in a code block, Use the $sign function, and don't forget the await keyword. The function will find the first element that matches the given EF and return it as a web element. A web element is a class defined by WebDriver.js, which is the framework built on top of WebDriver that is used by Smashtest. From here, you can do anything that WebDriver.js can do, such as do assertions or call functions on LM. The $sign function will throw an exception if a matching element cannot be found in time, which is 2 seconds by default. Because of this, it is frequently used to verify stuff on the page. Although this call will return the login box web element, we don't really need to save it to a variable, since all we're doing is making sure the element is there in the first place. Now, why not just use the verify ElementFinders visible step? Well, we could, but as we'll see shortly, EFs can be complex and span multiple lines. The standard verify step can only take a short and sweet single line EF. Worth mentioning is the fact that the $sign function scrolls to the element it finds, just like a real user. You should take that into account if your app is sensitive to scrolling. The $sign function finds and returns an array of all the elements that match the given EF. It's pretty much the same as a single $sign function in every other way, except that it doesn't do any scrolling. You probably won't use this function as often. So check this out. Run a test and debug or open up the REPL with the -r flag. If you type a quoted EF into the console, it'll attempt to find it on the page and output the number of elements that were found. If you open up the browser console in DevTools, you'll find all the search logs for the EF you just entered. Here's the element that was found. In search details, it will tell you how the EF was divided into props and show you the pool of matching elements before and after the props are applied. Under Apply Each Prop, it will show the details of how each prop is applied. So for visible, here's how visible is defined and the pool of elements before and after it's applied. Remember that we start with all elements in the DOM and wither it down as each prop is applied, left to right. The same is shown for the next prop as well. This feature is very convenient when debugging a failing test. Why didn't anything on the page match this EF? Well, this will tell you why. I also recommend playing around with this feature in your free time to learn more about how props behave. Trust me, you'll learn to love this thing. Now let's go over some advanced EFs. First, there's the not keyword. Simply put, it negates the prop that comes after it. If an element matches the prop, it doesn't match not prop, and vice versa. Attach not to any kind of prop. Counters tell an element finder how many elements to match. When not explicitly stated, different functions set different default counters. For example, the single $sign function will attach a counter of 1 to the EF you pass in. The $sign function will attach a counter of 1+, since you're trying to match as many elements as possible. Explicit counters come before the props list and are separated by an X character. When the counter is a single number, you have to match that many elements. If more matching elements exist, that's okay. Only the first N are chosen. If fewer elements exist, an error will be thrown. You can add a plus sign or a hyphen to indicate no upper bound. 0 or more means match as many as you can, but 0 is fine too. If such an EF is passed to the $sign, an empty array is returned. No errors, no worries. For numbers 1 or greater, it'll match as many elements as possible, but will throw an error if fewer than n exist. When you pass in a range, it will try to match as many elements as it can within that range, inclusive. If there are more than the upper bound, only the first upper bound elements are matched. And of course, if there are fewer than the lower bound, an error is thrown. This element finder spans 4 lines, where each line itself is an element finder. It searches for an element of class list, which contains a child element with text 1, a child element with text 2, and a child element with text 3 in that order. This is a subset matching, meaning other elements may exist in and around 1, 2, and 3. Here's the same EF used inside a code block. Just like with steps, each indent is exactly 4 spaces, and the top parent, .list, can start at any indent that's a multiple of 4. The $sign function will return the list element if found, though in this case, all we're doing is verifying the list exists. This is actually the most common pattern for verifying multiple details on a page. You have a generic verify step with code block and a $sign call with a multi-line EF. Don't do it the old school way with multiple verify steps in a row. All you need is one step with a single detailed EF. Now let's take a look at more features of multi-line EFs. Here we use the special any order keyword. This just means the 3 children, 1, 2, and 3, can be in any order so long as they're all inside a list. Instead of matching a list element, this EF will match a to element. We're still looking for a list with those 3 children, but the to element will be nitpicked and returned as your matching element. You can match multiple elements by using the brackets in more than one place. This EF will match a 2 and a 3 element. Be careful when using CSS selectors that start and end with square brackets, by the way, since they may be interpreted as a matching operator. Instead, use the selector prop to prevent ambiguity. What happens if you have multiple lines at the top indent, like so? Well, it will assume the document body is the parent, like so. So it won't match 2 elements. It'll match the body, assuming it contains 1 and 2 in that order. Let's cover one last thing about element finders, the element array. This is an amazing tool for doing verifications once you get the hang of it. Here we're finding a list. Then there's a funny line that starts with an asterisk. This is the element array. It means match as many elements under list with the class item. Under that line, we have 3 children, 1, 2, and 3. These children must match the element array's matches 1 to 1. That is, if you take all children of list that have class item, there must be exactly 3 of them in that exact order containing that text. If it's something else, be it 4 items or 2 items or the correct items but in a different order or 3 items with slightly different text, then an error will be thrown. This kind of strict validation is great for verifying things like lists, where you want to get the order and number exactly right. And as shown before, you can use any order to allow any ordering, so long as you still get the number right. Element arrays work with 0 elements too. So here, the does not exist prop matches 0 elements, and rightfully so, no children are listed underneath it. This EF won't cause an error. All right, there you have it. Web UI steps and element finders in a nutshell. We covered a lot here, so take a breather and play around with what you've learned already. If you've watched all the other lessons up until now, you should know enough to build solid web UI tests in Smashtest. Give yourself a well-deserved congratulations. Now, excuse me while I do the whole YouTuber thing. To get notified when the next lesson comes out, subscribe, like, and/or comment. I'd love to hear your feedback, especially if you've made it this far, as this means you probably see value in Smashtest. What are you using Smashtest for? What do you like about it? What don't you like about it? What do you think of the course so far? You can also find help and engage the community on Gitter and GitHub. All links are on smashtest.io. In the next few lessons, we'll be covering slightly different topics, such as workflows, selective test running, parallelism, API testing, and I'll probably throw in a hands-on tutorial or two, just so you can see the whole test writing process in action, start to finish. Hope you're excited. See you there.